Hi everyone, today we're going to keep going with our graph sketching unit. This is day 3, and what we're going to be doing is pulling together everything we've learned so far so that ultimately we can actually sketch our graph based on what we know. So if you look at the top, we're going to be finding everything. We're going to be finding critical points, points of inflection, where it's increasing and decreasing, concave up and concave down, all of our extreme values, and then we'll be using that information to sketch a picture of the graph. So we're going to start off the same way we have been this whole chapter so far. So the first thing I'm going to do is find my first derivative, right? Remember, this is going to give me the critical points and ultimately the information on where I'm increasing and decreasing. So my first derivative is going to be 3x squared minus 12. I'm going to set that equal to 0. And so if I factor out a 3, I've got x squared minus 4. And then I like putting it in its fully factored form because it helps me later when I go to test my intervals. Okay, so I can see now that my critical points are at -2 and 2. Let me do this. So I've got x equals -2 and 2. I'm going to hold off on my table for a little bit here. So what I'm going to do next is find the second derivative. And this is a nice, easy one to deal with. My second derivative is 6x. And I know that's equal to 0 when x equals 0. Now remember, I'm not actually going to list that as a point of inflection yet, because for it to be a point of inflection, I need to know that the concavity actually changes there. So I'm going to wait till we do the table to verify that that actually happens. So let's go ahead and build our table. And in that table, we're going to have our critical points and any possible points of inflection. So I don't have a closed interval. I'm going from -infinity to infinity. So I have -infinity, a critical point at -2, possible point of inflection at 0. Extend my table a bit here. Got another critical point at 2, and then that goes off to infinity. So now I'm going to test values. So I'm going to pick a -3 for this first box. So -3 is going to give me a negative here times a negative. So I know I'm going to be positive. So f is increasing on that interval. Now remember, between -2 and 2, I only need to pick one point, and I'll know both of these boxes. So I'm going to pick 0 because that's obviously the easiest. If I pick 0, I have a negative times a positive, so I'm going to be negative over that. So I know that f is decreasing there. And last but not least, if I pick something greater than 2, I'm going to have positive because all my factors will be positive, which tells me f, the actual function itself, is increasing. So now let's look at our second derivative. I only have one possible point of inflection, so there's only 2 points that I need to pick, something less than 0 and something greater than 0. So if I pick something less than 0, my second derivative is going to be negative. That's telling me I'm concave down. And something greater than 0 makes me positive. So I'm going to be concave up. So before we start trying to sketch this, let's figure out what's going on here. For points of inflection, at x equals 0, I do change signs, my concavity. So I know I have a point of inflection at x equals 0. I'm increasing where my first derivative is positive, so from -infinity to -2, and from 2 to infinity. I'm going to be decreasing where my first derivative is negative, so from -2 to 2. Okay, concave up. I'm looking for a positive second derivative, so that happens from 0 to infinity. Again, this is an open interval for that second derivative. Concave down is going to be -infinity to 0. Now, it's asking just for the locations of my maxes. So remember, those are just x values. So what I'm looking for, really, remember we said we have a maximum where our derivative changes from positive to negative. So in this case, that happens at one point here. From positive to negative happens at -2. My minimum location, I know that happens where f prime changes from negative to positive. Negative to positive happens at x equals 2. This is all the stuff you guys already know how to do. So all that's left is to take all this information and plot it on a graph. Now to do that, I'm going to get some y values here so I know where to plot some of these points. So I'm going to take -2 and I'm going to plug it into my original. So maybe I'll put some work down here. F of -2. -2 cubed is going to be a -8. A -12 times a -2 is going to be a +24. And then I have -5. So -8 plus 24 is going to give me a +16 minus 5 will give me an 11. So f of -2 is equal to 11. If I plug in 0, that's an easy one. I just get -5, so that gives me another point. And then last, I just have +2, so f of 2, let's see, 2 cubed is 8. Now I have -2 times 12 is 24, -5. So I have -16 minus 5 is a -21. All right, so let's see. I'll give myself more space in the negative. So this is 1, 2, counting by ones there, and I have to go to -2 on this side. Now let's see, my biggest positive is 11. I'm going to count by, let's do 5s. So there's 5s, and then we'll do 5s here. So 5, 10, 15. I need to extend this. Okay, just to scale it out a bit. So now I'm going to plot my points. I've got -2, 11, so about here. I've got 0, -5, and then I've got 2 and -21, so right about here. So now I'm going to use this table to kind of help me figure out what's happening. I know from -infinity to -2, I'm increasing and concave down. So I'm probably going to look something like that. F is increasing, but it's also concave down. Now from -2 to 0, it's decreasing and concave down. So now it looks something like this. From 0 to 2, I'm still decreasing, but I turned to concave up. So it's going to look something like that. And then last, I'm concave up and increasing, so it looks like this. So it looks like I'm putting together something like this. So now I just have to fit that same behavior to my points here. So let's see. We said, I'm going out of the box here, I know, a little bit. So from there, then I come down here, decreasing and concave up, and now increasing and concave up. Again, it's a rough sketch, but it's a pretty good sketch of what it looks like. And we can actually check. If we put this in our calculator, I'll go ahead and do that. X cubed minus 12x minus 5. All right, you can see we kind of fit that same behavior here. Here's our increasing concave down, decreasing concave down, then it switches to decreasing and concave up, and then back to increasing and concave up. So that's how this is going to work as we pull it all together. So now we'll just do one more. I probably won't talk as much through the individual steps. If you feel like you've got this, it's probably a good idea at this point to pause it, try number 2 on your own, and then compare it to what I've got. Okay, so here, let's go ahead and try number 2. Again, looks like a pretty straightforward function. Shouldn't give us too much trouble. So let's see what we've got here. All right, so f prime of x is 4x cubed minus 12x squared, and I want to find where this is equal to 0. Again, looking for those critical points. So I can factor out a 4x squared, and then I have x minus 3. So that's going to be 0 where x is equal to 0 or 3. Then I need to find my possible points of inflection. So I take the second derivative. So I've got 12x squared minus 24x equal to 0. I'm going to factor out a 12x. I have x minus 2. That's equal to 0. And so now I have possible points of inflection at x equals 0 and 2. So again, now we're back to our table here. So I'm going to put f prime of x and f double prime of x and plot in all our points. So I've got negative infinity and then 0. So 0, and then I've got 2. Extend my box here, put my last critical point 3, and then I've got infinity at the end point there. So less than 0, this is going to be positive times a negative will be negative. Now I just need to pick one point between 0 and 3, so we'll test 2. We're going to have a positive times a negative. This is going to stay negative. And then for greater than 3, that's going to give us positive. So I know f is actually decreasing along this whole interval here, and then only increasing from 3 to infinity. Let's see, now 0 and 2. So less than 0 is going to give me a negative times a negative, which is positive. Between 0 and 2, I'll pick 1. So I have a positive times a negative. It's going to be a negative. And then greater than 2, let's see, positive times positive is going to be concave up over that whole interval. So I've got positive, then negative, and then positive, positive. So we can fill in our table again. Critical points were at x equals 0 and 3. Now for points of inflection, we had 2 possible points. So if I check 0, I see that I did change sign from positive to negative. And at 2, I changed from negative to positive. So those are both points of inflection. We're only increasing here from 3 to infinity. And we're decreasing everywhere else, so from negative infinity to 3. I'm concave up from negative infinity to 0, and then from 2 to infinity. And I'm concave down, let's see here, from 0 to 2. Now again, maximum locations. Again, I'm looking from where f prime changed from positive to negative. And so we actually don't have any there. So we don't have any maximum locations. And then for minimums, I'm looking where it changes from negative to positive. And I can see that does happen at x equals 3. Now keep in mind, we said we might not have any maximums, especially when we're on an open interval like this. So when we look at the graph, we can verify or validate that we shouldn't have any maxes. So let's find our y values now. So for 0, that's just going to be 0. If I have 2, let's see, f of 2 is 2 to the 4th minus 4 times 2 cubed. So I have 16 minus 2 cubed is 8 times 4 is 32. So negative 16. And then f of 3 is going to be 3 to the 4th minus 4 times 3 cubed. So we have, let's see, 3 to the 4th is going to give us 81. Minus 27 times 4 is 108. So 81 minus 108, we get negative 27. Okay, so now I'm going to start by plotting those points. So let's see, most of this is positive x here, and my values are going to be negative, so I'm going to give myself more space on the negative end here. So let's see, 1, 2, 3, counting by ones there, and then I need to get to a negative 27, so we'll go by 5s again, 10, 15, 20, 25. And let's plot some points. So let's see, I have 0, 0. I have 2, negative 16, and then 3, negative 27. So down here. Now, let's look at that behavior again. We said we were decreasing and concave up, so I have something like that. Then I go to decreasing and concave down, so it changes. Decreasing the concave up again, and then increasing and concave up. So it looks like I have a behavior, I would say something like that. So let's fit that to the points that we have. So this is decreasing and concave up, decreasing and concave down, decreasing to concave up, and then increasing and concave up. So something like this. This should be a little smoother here. There we go. And so I graphed this just in the standard window so we don't quite see everything, but you can see that behavior there is the same behavior. All right, so this is just a couple of quick examples of how we pull this all together. And then obviously when we come back, you'll have a chance to practice this. So that is it for today. Thanks.